Have you ever wondered how the sun's energy can power your entire house? It's a question that's been gaining more attention, and rightfully so. As we look to the future, the importance of renewable energy sources becomes increasingly apparent. These aren't just the latest buzzwords in the world of science and technology, they're the keys to a sustainable future. One of the most promising of these renewable sources is solar energy. It's not just about soaking up the sun, it's about harnessing its immense power and converting it into something we use every day: electricity. In the United States alone, the solar industry has been growing exponentially, showing immense potential for the future. This isn't just a trend, it's a revolution in the way we perceive and utilize energy. So how does this fascinating process work? Let's dive into the world of solar panels and discover the magic behind them. Solar panels may seem complex, but at their core, they have a simple and elegant design. Let's start with the basics. A solar panel is composed of three primary components: solar cells, semiconductor material, typically silicon, and an inverter. Solar cells are the heart of the operation. They're the ones basking in the sunlight, absorbing photons and initiating the process that converts sunlight into electricity. These cells are typically arranged in a grid-like pattern on the surface of the solar panel to maximize exposure to the sun. Now let's talk about the semiconductor material. Silicon, a chemical element with photovoltaic properties, is the most commonly used. When sunlight hits the silicon cells, it energizes their electrons. These newly motivated electrons move around, creating an electric current. It's a bit like a dance party for electrons, with sunlight playing the role of the DJ. Last but not least, we have the inverter. This unsung hero of the solar panel system converts the direct current produced by the solar cells into alternating current. Why is this important? Well, most of the appliances in our homes use alternating current, so without the inverter, we'd be stuck with a lot of electricity and no practical way to use it. Just to put it into perspective, imagine baking a cake without an oven. You have all the ingredients, you've mixed them perfectly, but without the oven to bake it, you're left with a bowl of raw batter. The inverter is essentially your oven in the solar panel system. So, in a nutshell, solar cells absorb sunlight and generate an electric current. Silicon acts as a dance floor for electrons, and the inverter transforms this energy into a form that powers our daily lives. Now that we've got a handle on the basics, it's time to understand how these components work together to harness the sun's energy. The magic starts with something called the photovoltaic effect. A term that rings like a spell from a wizard's book, isn't it? Well, in a way, it is quite magical. The photovoltaic effect is the process that allows solar panels to harness the sun's energy and convert it into electricity. It's the linchpin of solar energy technology, the wizardry that turns sunshine into power. The photovoltaic effect was first observed in 1839 by a French physicist named Edmond Becquerel. While experimenting with an electrolytic cell, Becquerel noticed that the cell produced more electricity when it was exposed to light. This was the initial discovery of the photovoltaic effect, and the first step towards the solar technology we have today. So how does this photovoltaic effect work? It all starts with photons, the tiny particles that make up sunlight. When these photons hit a solar cell, they can transfer their energy to the electrons in the cell's atoms. This added energy kicks the electrons into a higher state of energy, creating what's known as an electron-hole pair. The electron, now in a state of high energy, is free to move around, and this movement is what we call electricity. Each solar cell is designed to create a path for these high-energy electrons, guiding them into a flow or current. This current, together with the cell's voltage, defines the amount of power the cell can produce. The more sunlight that hits the cell, the more electron-hole pairs are created and the more power is generated. But it's not just about the number of photons that hit the cell. The efficiency of a solar cell, that is, how much of the sunlight's energy it can actually convert into electrical energy, also plays a big role. This is where advancements in solar technology come into play, with researchers constantly seeking ways to increase the efficiency of solar cells and make solar power a more viable energy source. The photovoltaic effect sets the stage for the solar cell to do its job. But what happens next? Well, that's a story for another scene. For now, let's bask in the brilliance of the photovoltaic effect, a true marvel of engineering. The sun has done its part, and now it's the solar cell's turn to shine. Imagine yourself as a photon, a tiny particle of sunlight. You've traveled 93 million miles from the sun. And now you're about to embark on a critical mission, knocking electrons free in a solar cell. Now you might be thinking, electrons, photons, what's all this about? Well, let's paint a clearer picture. In the heart of each solar cell, there's a party going on, a party of atoms, each with its own set of electrons. These electrons are just waiting for an invitation to dance, and that's where our photon friends come in. As a photon hits an atom, it gives an electron enough energy to break free and start dancing. Or, in more scientific terms, to move freely. This movement of electrons is what we call an electric current. But wait, there's more. These electrons are like toddlers, full of energy, but they need guidance. That's where the solar cell's built-in electric field comes into play. It acts like a shepherd, guiding these electrons in a specific direction, creating a flow of electric current. Now we've got a current, but it's not quite usable yet. It's in a form called direct current, or DC, which is like a one-way street for electrons. However, most of our home appliances need alternating current, or AC, a two-way street for electrons. This is where the inverter, a key component of a solar power system, steps in. It's like a translator converting the DC from the solar panels into AC, the language that our appliances understand. In a nutshell, that's how we go from sunlight to electricity. It's a grand journey, a space odyssey of sorts, from the core of the sun to the heart of our homes. All thanks to the marvel of engineering that is the humble solar cell and the magic of the photovoltaic effect. So we've got our electricity. But how does it get from the solar panel to power your home? It's a sunny day, your solar panels are hard at work, and you're ready to enjoy some free, renewable energy. Let's dive into how this energy generated by the solar panels travels to your home's electrical panel. Picture a bustling city highway filled with energy-powered vehicles zipping along. That's essentially what's happening when sunlight hits your solar panels. The energy generated needs to go somewhere, and that somewhere is your home's electrical panel, the heart of your home's electrical system. Now, this energy doesn't just randomly scatter throughout your home. There's a method to this energetic madness. Your electrical panel works like a sophisticated traffic controller. It directs the incoming electricity to various circuits that power your appliances and other electrical devices. Think of it as your personal energy concierge. Need to power up your refrigerator? It's on it. Want to charge your electric car? Consider it done. From your morning toast to your late-night Netflix binge, your electrical panel ensures that the power derived from your solar panels gets to where it needs to go. But it's not all about powering devices. Safety is crucial. If there's an overload, your electrical panel steps in, shuts down the circuit, and prevents any potential damage. It's like a superhero protecting your home from the villainous power surges. Of course, not all the power generated by your solar panels will be used immediately. Any excess power is typically sent back to the grid, and you'll often receive a credit from your utility company. It's like having a piggy bank of solar energy for those less sunny days. So, in essence, your solar panels and electrical panel are an impressive tag team. They work together seamlessly to harness the power of the sun, convert it into usable electricity, and distribute it throughout your home. And just like that, the sun's energy powers your home. But let's recap what we've learned today. Solar panels may seem like a complex piece of engineering, but when broken down, it's a simple and beautiful process. We've taken a journey today, starting with the basics of solar panels, those sleek surfaces fitted with silicon cells. We delved into the photovoltaic effect, a natural phenomenon that feels almost like science fiction. Sunlight striking a material and generating electric charge. Then we followed the journey of a single photon, from the sun's fiery surface to your living room light bulb, explaining how sunlight is converted into electricity. And finally, we looked at how this power can be harnessed to heat your morning coffee, power your laptop, and light up your home when the night falls. It's a wonderful dance of photons and electrons, a testament to human ingenuity. Harnessing the power of the sun might seem like magic, but it's really just good, clean engineering. Until next time, stay curious and keep exploring.